Alright, so this is Chapter 8, Trig Substitution. If you can remember your arcsines and arc cosines and arc tangents and all that, and the problem applies directly to one of those, like number 1 and number 2 does, fantastic. But the second they're out of order, it kind of runs out of play. So like if this x isn't here, it's not an arcsecant. So what in the world do you do? So if you remember back to when we created the derivatives and antiderivatives of arcsines and cosines, we drew a triangle. So we're going to do the exact same thing here. So we're going to draw a right triangle, and in that right triangle we're going to put the information we see here. Now the positive thing is always going to be the hypotenuse, because a squared plus b squared equals c squared, and c squared is always going to be the positive thing. So if you got both things adding up, then that's going to be the hypotenuse. If you get something subtracting, so like the x squared is being subtracted from the 9 is the hypotenuse. Well, more along the lines of the hypotenuse is 3. One of the sides is going to be x, and the other side is going to be kind of what we have here. It's going to be the square root of 9 minus x squared. Anytime you have a subtraction in here, it's always one of the sides. Now these two sides could be switched, but for consistency, we're going to put the more complicated side on the opposite of our angle, because all of our angles are going to be bottom left here, and the easier side on the close side. So if we have the choice, we'll put the more complicated side opposite and put the easier side close. We don't really have a choice about the 3, because the 9 is the positive part that has to be the hypotenuse. So you get a squared plus b squared equal to the c squared. C is always positive. Alright, so we've got our triangle set up. Now we just really need to come up with a dx, and we need this square root. And we're going to write them all in terms of theta. Alright, so I want to, well, let's find our square root easier. So when I've got my square root, that's my opposite side. I can either do the opposite over the adjacent, that would be tangent. However, I don't have any x's in the actual problem, so I'd rather do my opposite over my hypotenuse. So it's the sine of theta equals our square root of 9 minus x squared, that's our opposite, over hypotenuse of 3. So that's our sine. So where I see that in the problem, and multiply by 3, I'm going to replace my 9 minus x squared by 3 sine theta. So we got the integral 3 sine theta. Now the only thing is I need this dx to be in terms of theta. So I need to go back to my triangle, and I need to write a trig function that relates x to theta. Now I want to avoid the opposite because it brings in that square root. So x is my adjacent and the 3 is my hypotenuse. So that's a much easier thing to use. So we use cosine of theta equal to x over 3, adjacent over hypotenuse. So I'm not looking for x, I'm looking for dx. So we multiply by 3, and we're going to take our derivative, find dx. So negative 3 sine theta equals dx. Alright, we plug that in for our dx. Negative 3 sine theta d theta, because I should have a d theta here. And look what happens. The 3's cancel, the sine of theta cancels, the sine of theta cancels, and I get negative integral of d theta. Well, what is that? That's negative theta. Now, I can write more than one equation for theta. I could go back to sine of theta and have the arcsine of this craziness, or I could go back here to cosine of theta and say, well, cosine of theta was originally just, get rid of this divided by, remember? Cosine of theta was adjacent over hypotenuse. Cosine of theta was my x over 3. So that means that to find theta, cosine inverse of x over 3 equals theta. So I've got the arc cosine of x over 3. Well, I have the negative out front, negative arc cosine. Of x over 3, and then plus c. Now, if you think back to what you were hopefully remembering, is that this is really the arcsine of x over 3. Well, arc sine and negative arc cosine are the exact same thing. So this is really arc sine of x over 3 plus c. And so the question is, why do we get this result versus the arc sine? Well, it really depends on which side you make opposite. So if you made the x be the opposite and the root 9 minus x squared be the adjacent, you would get the arc sine instead of the arc cosine. But we chose to put the more complicated side opposite, so we got our negative arc cosine.